all in the last technical session, 10th A, based on productivity enhancement and process optimization 2. This is a parallel session and technical session 10th B on sustainable construction practices and use of alternate aggregates is going on in Ashoka Convention Hall. We are honored by the presence of Shri K. Vinayagamurthi, Executive Director, Dalmia Cement Bharat Limited. We request you, sir, to kindly come on the dais and chair the session. Thank you, sir. May I now invite Shri Dinesh Kumar, Senior Vice President, Prism Johnson Limited, to kindly join our respected chairman and co-chair this session. Thank you, sir. I would also like to call Shri Suresh Shaw, Group Manager as NCB representative, to kindly join the dignitaries on the dais and start the proceeding.
So, good morning all.
Good morning.
And welcome to all the delegates. And I am honored to welcome our two eminent personality, co-chairman as K. Vinayagamurthi and co-chairman Shri Dinesh Kumar ji. And this session is about productivity, enhancement and process optimization. And this is a very important session. Now, I request Chairman Sir to take up the session.
Thank you, Suresh. Good morning to all of you. Yeah, we will go to the session straight away so that we will save some time. So now I invite the paper on innovative approach to increase the CVRM PPC productivity and reduction of specific power consumption.
A very good morning to our Honorable Chairman, Co-Chairman and the NCB representative. Myself Arun James, representing Dalmia Cement Bharat Limited, Arilur plant. And the title of my paper is Innovative Approach to Increase CVRM PPC Productivity and Reduction of Specific Power. So I'll take through the contents of group and plant profile, project background, approach methodology, brainstorming with the conclusions. So starting with my group profile, it was founded by Shri Jayadal Dalmia in 1935. It's a pan-India presence in cement business. We have 14 plants across 10 states with a capacity of 35.9 million tons per annum. We are the fourth largest cement manufacturer in India. We are manufacturing special cements like oil well, air strips and railway sleeper grade cements. Apart from cement business, we are also indulged in the manufacturing of power, sugar and refractories. Coming specifically to the plant profile of Arilur, we have 2 million ton per annum capacity of clinker and cement capacity of 3 million ton per annum. Also, we have a captive power plant of 27 megawatt and a solar power plant of 11 megawatt to the peak. We produce OPC, PPC cement, and we are also indulged in the production of blended cements like DAP and DSP. So the background of this is we have a cement mill, one mill operating with, it is a 5600 BC of FIFER make, and it is operating effectively with the 370 TPH at 23 kilowatt per hour of metric ton, against the OEM design of 300 with a specific power of 28 kilowatt per hour. So we had tried to increase the mill output more than the 370 TPH, but the mill restricted by its increase in the DP and mill vibration and the increasing table load due to recirculation of the material. So we have taken the challenge to increase the output and reduce the specific power. A detailed study was taken through the velocity and pressure profile throughout the mill, starting from the nozzle ring, dam ring area, and rollers and the classifier area. So we found that there is a gradual increase in the velocity from the grinding zone, and it is a sudden drop in the classifying zone. In addition to it, we were not able to increase the velocity because of the less efficiency of the fan, which is about 78%. So we had a brainstorming session, and finally we decided to increase the velocity in the classifier area and upgrade the fan with a high efficient impeller. So fishbone methodology was used for increasing the output and reducing the specific power, considering the categories of man, material, machine, and methods, in which the dominant constraints are observed in mill DP, airflow, mill velocity, and mill main drive. We have taken the process parameters and MIS reports for the last 6 months and used for this analysis. Increase in the CVR and PPC productivity and reduction of specific power. So as it is displayed to the left is the profile which was before. After the nozzle ring, the velocity was starting from 4.5, 5.5, 5.8, and there is a drop in the classifier area. So we decided to make annular block over the mill and try to increase the velocity, which could extend up to 8 meters per second. We used 3 meter by 6 mm thickness of plate to block the nozzle area. So as an output, the classifier inlet velocity increased from 5 to 8 meters per second by the reduction of annular gap, and thereby the mill internal recirculation load has been completely reduced. It has also reduced the table load. Ultimately, the mill differential pressure was reduced by 20 milligram and increased the TPH by 20 to 30 TPH. After this modification, the mill output was increased to more than 400 TPH, or around 410 TPH. The total investment which we took for spares and services was around 2 lakhs, and the specific power was reduced by 0.3 kilowatt. This specific power reduction sums around 853 tons of carbon dioxide reduction, emission reduction per year. So the second one is this fan, which we had a constraint. It was upgraded with the increase in the diameter from 2,780 to 3 meter, and the fan efficiency was increased from 78 to 83%. In turn, we had a power saving of 148 kilowatt. So to conclude, finally the feed increased from 370 to 410 TPH in PPC grinding without compromising the quality parameters of 3,600 centimeter square per gram. The mill pressure drop was reduced from 300 to 270. The mill fan efficiency was increased from 78 to 83 and saved around 148 kilowatt. The specific power was reduced from 22 kilowatt to 19.8 kilowatt in PPC grinding. So finally, the reduction of CO2 for 853 tons by reduction of power consumption per year. Thank you.
Thank you, Shri Arun from Dalmia Cements. Now I invite the paper on process optimization by implementation of Industrial 4.0.
Yeah, respected chairmen, co-chairmen, and the NCCM team, and my dear friends, happy morning to all of you.
Morning.
Myself, Rajendran from Dalmia Cement, Arilur, Tamil Nadu. I would like to thank to NCCM for giving this opportunity. You know that Dalmia is very keen to updating new technology, and I am happy to share that our Arilur unit is pioneer in this among our group. Today the topic is process optimization by implementation of new technology in the part of Industrial 4.0. So this is our content. So what is the requirement of Industrial 4.0? So we know that complex process and cement from raw material grinding to our finished products. And the next one is quality. So if you want to sustain in the market, you want to sustain the qualities. And also that for nowadays we are having more challenges in the quality when you are using the alternative fuels. And suppose next one is it is the productivity. Suppose you want more productivity and more reliability, very important. Next one is KPI monitoring. Suppose we are having more data in our diesel system, but that one person cannot monitor all the data. So overcome all those challenges, Industrial 4.0 will be a good solution. So this is Industrial 4.0 application of our cement plant for enhancing productivity, reliability, and energy front. So generally we will use a conventional PID for auto loop control system. So there is some limitation in the PID, but so now we have switched over to model predictive control. So there is no limitation. Example, we can give number of inputs, number of outputs. Then I can create my own model, some soft sensors and fuzzy logic and functions, whatever I need. So it will be a more advantage of cement applications. And one more advantage of this MPC, you have prediction. So next another 15-20 minutes, what will be my productivity and quality, I can judge that. And I want to share one case study process by pre-culture optimization. I believe that every plant having challenges, optimization of pre-culture when using alternative fuel. We also face the same. So this is, I'm showing that this graph shows that manual control. So suppose my temperature target is 890, so I never meet my target, and also temperature variation is above 40, plus or minus. And the CO in the circuit above 7,000 ppm. This slide shows that process optimization with the help of model predictive control. So we are actually my target, my actual PC temperature close to my target, and we can see that the variation of temperature is very less than 20 degree, and the positive side, minus 6 degree in the negative side. And there is no, the CO is less than 500 ppm. This is a standard reduction, so comparison between manual and model predictive control. So we can see while operating the manual, the standard deviation of the temperature is above 70 degree, and while operating at the MPC, I can bring down to less than 17 degree. Same like CO, suppose we are operating in manual, the CO will be 7,000 ppm, and sometime it goes to 10,000 also. Suppose when operating with the MPC controller, I can bring down to less than 500 ppm. Here I want to show just one more example of this, our mill standard deviation. So this is the benefit of mill standard deviation reduction. We are utilizing for all the mills, just I show only raw mill example here. And the next one is quality control. We are having robot technology for quality control. We are having sampling station in all the locations, and we are having collecting, receiving, and analyzing and monitoring control in central control lab. This is the process of robotic control lab: sample collection, receiving, sample processing, analyzing, monitoring, and control. So this is my sample status report. From this report, I can identify where is my sample. It is collection state or receiving state or progress state. So I can see that. From this, suppose if it is under progress, it will show progress. If it is all the process completed, it will show completed. These are sample reports. So I can access the report, and I can see the quality parameter from anywhere in the plant. With the help of robot lab and MPC controller, we made the closed loop action. So there is no need manual intervention for blendings. So with this result of robot lab, the result will be sent to MPC controller. MPC will act against our target. So always 100% will be automated. So this is the benefit of the MPC controller. So we can see the difference between difference in the LS of standard deviation. While operating manual, the LS of standard deviation is above 3.5. While operating it MPC controller with the 2.2, sometime I will bring to 1.1 also, depends upon the situation. But you never go above 2.2. You know that everybody has stockpile analyzer in the plant, but the thing is that this stockpile analyzer will be monitored by plant team. So due to more load constraint, that plant team cannot monitor all the time. So he will monitor maybe after 40 minutes or 30 minutes. So that only after that he will communicate to our mines team. By the time many trucks will be left from the existing quality. So because of this, we are facing more variation in the LSF. So we decided that this quality parameter will be handed over to mines team over the internet. So the target will be given to mines team, so they can monitor the real-time analysis, and they can make the mixing accordingly. So we can achieve the LSF target. So next one is very interesting one. So we will call this a plant PIMS. It is a plant information management system. So we know that health is wealth. But the digital world, the data is wealth. If you are having more data, we can produce more solutions. So without data, we cannot do anything. So that's why we decided that we will integrate all the system to common platform. So we made it. So this function of this PIMS is making logs and productions and maintenance reports and breakdown analysis. Everything will be in the single platform. And automated alerts, everything will be available. So this is some snapshot of our plant information management system: KPI report, production, energy, and downtime report. So with this system, we have Pareto chart analysis. We can do the breakdown analysis, and we can find out the exact version of the system. So automated ones, every 1 o'clock we used to get the KPI reports automatically. without manual intervention. Next one is IoT-based asset monitoring system. So we have installed IoT sensor in all our VRM gearboxes. It was available with the local server as well as our OEM. Based on the AI, utilizing the AI, we have switched over from breakdown maintenance to planned maintenance. So whenever the IoT sensor available, it will give the alert. So the unexpected failure will be avoided. So we had many experience. So last month also we had one experience in our CVR gearboxes. So we had converted from breakdown maintenance to plant maintenance. So a plant dispatch and silo level accordingly. So it's a stress-free maintenance, we can say. Next one is remote monitoring system. Already I told that we have plenty of data in our OT system. So the data cannot monitor by single person. So what we did, we made the ownership of the data to ground level. So the data will be handed over to all the bottom level people, so they can take over their own data. Suppose if we have the data hand over to ground level people, if it is mechanical engineer, he can take care about our own equipment, like he is bearing temperature, vibration. If it is electrical engineer, he can take care about of our winding temperature and motor bearing temperature. So if we need deviation in this, that he can take immediate action, that maintenance will be planned accordingly. So apart from that, we made it this L1 to L3 level of monitoring. Suppose if I want the KPI, my specific it is my L1 parameter, then next what are the constants for L2 parameter? For in the L2 will be available specific consumption, accordingly L3 parameter available L2 parameters. So see the some of snapshot of mobile application, KPI monitoring. And also with the same cloud data we are using for web client view. And one more features we are having a smart client, so which is available on the DCS system, same display can available desk, so real-time monitoring possible from our office desk also. Then one more thing, tools we are having remote export tools. See, this is mainly from remote I can visualize and analyze my equipment, then I can give a suggestion. So this tool will give more benefit during a COVID situation, and also it will avoid the travel time. And we'll get the time support on time with augmented reality tool. This is some snapshot of the augmented reality tool. So next one is IT-OT integration. Suppose we want to enjoy the benefits of the OT systems, because now we are more advanced in OT system, we want to enjoy the OT system. This IT-OT integration is very essential. That's why we integrate IT-OT system with the secured firewall and scanning system and cyber backup system for accessing the OT system through our IT and as well as our network. This is the conclusion. By implementing Industrial 4.0, we get more benefits: increase in the productivity, reduction in the specific energy consumption, reduction in standard deviation, and increase in consistent alternative fuel consumption, consistency in quality and productivity, increase reliability, reduction in MTTR and MTBF, right information at the right time, and carbon reduction. So this is our way forward. Actually now we are having artificial intelligence, and we are trying to move 100% with self-learning. So now this model, existing model, we have to tune accordingly our requirement. So we are planning to advance of this one. We have to do planning for self-learning and auto packing and loading system. IoT based, now we are having only IoT sensor for some critical equipments. We have to plan to go for all the equipments. And artificial intelligence using camera for process applications, finding the size of the material and the moisture analysis like that. And cyber security for strengthen the IT-OT integration system. So finally, I would to say that so changes will never change us. So we have to accept the changes for get the benefit of changes. Thank you.
Thank you, Shri Rajendran. Now I invite for presenting the state of our technology in cement industry. Now I invite the paper on improvising the kiln maintenance by virtue of strengthening the inspection checks.
A very good morning to respected chairman, co-chairman, NCB representative, and all my industry stalwarts. I am Kedar Gudbole from Ultratech Cement, Mumbai head office. I will be trying to speak something about how we can strengthen our inspection checks to improvise kiln maintenance. So these are the contents. What are the major factors affecting kiln performance? Maintenance categorized in inspection base and checks and inspection various. These are the major factors relating to kiln health performance. As a maintenance engineer or as a maintenance manager, all these things we need to take care. Whether the tire clearances, whether the shell deformation profile, thermal loading, ovality, fatigue, retainer ring, what are the conditions of retainer ring, roller shaft bendings, all these things cater to have a better reliable kiln. So we have tried to categorize the maintenance inspection methodologies in time-based, condition-based, and specialized checks and inspections. So these are some checks. As an engineer, we need to follow on daily basis. What are the migration or creep for our respective tires? Especially if the kiln is higher dimension or higher TPD kiln, around 10,000 or more than that. In such cases, even the higher migration creeps are allowed by various OEMs. What is the kiln actual floating pattern? I don't want my kiln to run at one static location, or else we will end up in either concave convex or a step formation onto upper support rollers. What are the supporting roller bearing temperatures? We need to keep check on it. As an engineer, we need to keep check on weekly basis for what is the kiln seals visual inspections. Say for example, at inlet or outlet, do we have any major leakages? Are they due to maintenance issues or are they due to process issues? We need to have a check of girth gear and pinion temperatures. What are the profile? We don't want to end up with any scratch or any progressive pitting onto our gear. What is the spray lubrication pattern? Whether my system is spraying and covering all the area, complete width of pinion and girth gear, so that it is lubricated and we don't have any metal to metal contact. What is the condition of our tire and shell? Whether the tire fixations, be it side stoppers or retainer rings or chair pads, guide blocks, they are in place or they are deviating. What is the temperatures profile of the shell of the tire, and what is the migration trend for that particular week. Coming to monthly checks and inspection, these are quite critical one. How the support rollers are thrusting my kiln. Usually all the support rollers, or at least 4 to 5 support rollers, shall push my kiln slightly upwards, because kiln has a tendency to come down. What is the contact pattern? Contact pattern means whether we are having 70–80% at least contact between the tires and rollers while they are rolling. What is the supporting roller bearing temperature profile? Say for example, I don't want to end up with hot bearings either in radial or axial direction. Kiln visual inspections of the drive, whether there are any leakages from our gearboxes, how is my lubrication system behaving, and stroboscopic inspection. Stroboscopic inspection gives us a quite detailed idea that what is the condition of my gear. On quarterly or half-yearly basis, it's recommended to have lead wire test. Nowadays, very few plants are doing it, but it really gives a nice picture that how the load pattern is, how these support rollers are skewed, how the load is being transferred from the tire onto the roller. We need to have oil sample analysis of our support roller bearings. Also, we don't want to over-lubricate or under-lubricate our drive. So whether our grease consumption for the drive is optimized or not. This is a very critical thing. During our plant shutdown or yearly shutdown, These are the checks which we shall not miss. The NDT, ultrasonic testing or magnetic particle inspection, tire and roller surfaces rectile and reti. We need to measure whether our tire or roller, they are perfectly concentric or not, they are perfectly round or not. We don't want to have taper wear, we don't want to have concave or convex wear. What is the actual position of the tire with respect to kill position in cold condition? Because we don't want to end up with overhang of the tire during hot running. What is the wear of our girth gear? We don't want to end up in a catastrophic failure that it has worn out so high that we end up having some chunk out phenomena. Few more things like shell thickness measurement, seals detailed inspections, whether the riding ring is secured or not. Many times we miss to check this, and during operation the riding ring dislodges and we end up having any undesired stoppage. Outlet nose ring cooling. What are the nose ring nozzles, whether they are perfectly near to the outlet or not, whether they are not having any blockages. And every couple of years we need to measure what is the tire axial runout, girth gear radial axial runout. And every 3 to 4 years we shall inspect our support roller bearing liners. These are few specialized checks or inspections which we can do with help of special tools, even in running. We don't need any stoppages for it. We need to do hot kill alignment from either OEM or expert third-party service provider every 2 years. Thermography of kill inlet and outlet end. Why? Because there's a sort of a blocked vision zone for our shell scanners in most of the cases. We need to, we can use modern equipments like inductive distance measurement, which helps us to measure supporting roller shaft deflections or tire axial runout or girth gear runout even during running. We don't need to stop. The shell ovality sensor, it helps us to have a visualization whether there is more flexibility or more excessive flexing of the shell, which is affecting lower life of refractory just beneath the tire. Other tools like laser distance measurement, which helps us to have a detailed overview of how the shell profile is. Inclinometer we can use for inclination measurements of support roller, tires, girth gear, pinion. Telescopic contact thermometer, it's a very useful tool, not a very costly one, and it helps to have a feel of how the shaft condition is, whether we are having any minor grooves or any major depth. So these are checks we need to do, and what are the benefits we will get? If we measure all these things, we'll have a detailed inspections and detailed observation list with us, which will help us to schedule our manpower, to schedule our actions, to schedule the material related to overcome any deviations which we have seen. Thanks.
Thank you, Mr. Goyal. And as you all know, this kiln is the heart of any cement plant, and he has touched the key points. Thanks for that. Yeah. Now I invite the PEP. Yeah.
Am I one more?
Yeah.
Same. Yeah. The paper number is changed.
Oh, okay. Yeah, please continue. Yep. Now the paper will be on avoiding the bell mouth issue in the kiln shell and at the outlet.
Thanks.
Please.
Once again, good morning to all. So I would like to cover what is the bell mouthing or kill flaring This is a very neglected topic many a times. And the contents will be what is bell mouthing, how it happens, and what we need to do to avoid it. So usually a flaring or bell mouthing is nothing but the permanent enlargement of the diameter of a kiln shell at outermost end. So it could happen due to various factors, like major causes are overexposure. If it is more exposed to heat for a longer duration, or the axial thrust loads onto outlet sector plates is being transferred, we are having any failures of brick retainer which is causing, or any outlet sector plates failures, or the shell wear at the outermost end is excessively high. These are a few of the causes, and the conditions leading for these causes are: if we are having insufficient cooling, we are not properly cooling the nose ring, we are having failures of outlet sector plates, or the sector plates are worn out so heavily that we are having dust penetration of hot clinker dust, which is reaching our outlet shell. Or during any historical shell replacements, we have not measured the length properly, and slight excessive shell length we have installed, exposing our kiln more into cooler and not just at the end. So what are the measures which we can take to avoid such bell mouthing? We need to have a complete circumference of the nose ring cooling duct. In many of the plants, we find out that the nose ring cooling duct is not uniform throughout the circumference. It is hardly covering 50 or 70%. The benefit of complete circumference will help us to cool uniformly the new nose ring. Another things which we need to take care of. Various OEMs recommend to have the air for nose ring cooling within the range of 0.33 or 0.55 meter cube per second per meter of the kiln shell circumference. We need to have emergency power supply for nose ring cooling fan, which is a very neglected one. Very few of the installations I have found out that the nose ring cooling fan is having emergency power supply. We need to have kiln tripping interlocking with respect to nose ring cooling fan stoppage. And we shall operate our nose ring cooling fan such that it shall start before the main firing, and it should stop only when the shell temperature has gone below 100 degrees Celsius. During installation of the bricks, we need to ensure that the bricks which are sitting near the retainer ring are properly having contact with the retainer ring. The retainer ring itself is secured. We are not having any issues with the brick retainer ring at the outer end. And we need to timely inspect our sector plates. We need to control the liquid percent in clinker, because ultimately, if it is high, we are exposing more heat at the outlet end. So benefits of it will be, we will be having efficient nose ring cooling. We will have better life of our sector plates, of our outlet cowl shell, and the castable and brick lining at the outermost end. Thank you.
Thank you, Mr. Goyal. Whatever you have left in first presentation, we have covered in second, as far as the kiln is concerned. Good. Now I invite the paper on the correlation of chemistry and process parameters on formation of a light in portlet clinker.
Good morning, all.
Good morning.
Myself, Suresh Vanguri, and we are going to present this paper on correlation of chemistry and process parameters on formation of halite in Portland clinker. This is a joint paper. This is joint work between Ambuja Cements Limited, and NCCBM. So we will cover in 2 phases. So I will provide the introduction, and later part will be dealt by Mr. Jayaprakash. If we talk about the Industry 4.0, because we have been deliberating on this subject from the beginning of this conference. So basically what we are trying to do is, we are trying to have a link between a cyber world and the physical world. So whatever your artificial intelligence and computing and all these things, whatever you do in the cyber world, that we want to correlate with the physical world, so that whatever we do in the physical world will be more efficient, effective, and they consume less time and more profit. In the same way, we have tried this thing in process optimization or quality control. So in quality control, we know that we are using different advanced instrumental techniques. Now, the XRF has already become an integral part of the quality control, and slowly the plants are using XRD. Many plants are using the XRD, but still it is not as popular as XRF, but still we are trying to use advanced instrumental techniques. So when we are using these advanced instrumental techniques, we need to have the correlations. At the end of the day, we will have the lot of volumes of data, and if we do not have the correlations, then the data will not be used effectively. Particularly when we have new projects, like new greenfield projects, particularly in this case, where we do not have any indications. For example, if I change one parameter, how it is going to affect the other parameter. If I am going to change like LSF, how it is going to affect the properties of the clinker. If we do not have any prior indications, then these correlations will be very important. At least we will predict some properties of the clinker or cement. And also, even if in the case of established plants also, if we have these correlations, we can see whether we are adopting the correct solution methods, whether we are pressing the correct button, or we are changing the parameters of interest or not. That can be established by these correlations. So what we have done here is, we have selected some parameters, some quality parameters, some process parameters, and we try to establish the correlation between these parameters, because quality to quality is well known and process to process is also well known, but what is the gray area is, our quality to process is a little bit of gray area still now. So we try to establish that correlations also. Again, we try to establish correlation between quality parameters and in between among the process parameters, and also between quality to process parameters. And particularly this is very important when we come to the present scenario of using these kinds of alternate fuels. Now we do not know what kind of materials are coming into the plant, what kind of chemical composition is there, and how it is going to affect our mineralogy. All these things are not known, because now the industry is moving towards unconventional materials. Earlier we have all the conventional materials, we know the chemistry, we know the mineralogy, how they are going to affect the properties of the cement. But now, in a push towards the net zero, we are forced to use different kinds of materials, for which, for many of the materials, we do not know even the preliminary chemical composition also. So in these cases, these correlations will be very important, and particularly when we are using the alternate raw materials or alternate fuels, the most important parameters we have to see is the burning conditions, because apart from grinding and all these things, the main things we do in the cement plant is the burning and then cooling. So why we are doing this? Because we want to get some adequate phases, the mineralogy. So the mineralogy will depend on these burning conditions and cooling conditions. So that's why we try to include those parameters into the correlation concept. And this has been used for this new setup of greenfield project, 10,000 TPD kiln at Marwar, Rajasthan. So this is the experimental plan. These are the chemical mineralogical parameters, and these are the process parameters which we have considered. And of course, these are very old parameters, and people are using these parameters to monitor the quality of the product, and also to monitor the process. So all these parameters we have taken and we try to apply in the cement plant, where we try to optimize the process as well as the quality control. So with this introduction, I request Mr. Jayaprakash Vartiji to continue further. Thank you.
Thank you. Thanks for elaborating the things in detail. We don't want to make it more confusing or more complicated. So what we did that we have taken the data with the stable kiln operations and consistent fuel supplies. So as we go ahead with this, what we have observed that since we don't have the much of the data before starting our plant, we have only the exploration data with us. And then we have started with the new phases. The new phases are starting one by one. So we have a large variations in our process parameters as well as quality parameters. So we have, when we have summarized all these data, we found that we have a range of 86 LSF to 96 LSF in our clinker. So what we have done that we categorize these data in the three levels at 86, 89 and 92 LSF plus LSF. Here I will emphasize only on the lower LSF parameters because at the end we can conclude it very easily what we have achieved with this entire exercise. So we have what we have observed that with the 86 to 89 LSF, we could able to achieve halite up to a level of 66-67% through the XRD. So that was the eye-opening for all of us, that whether it is possible or whether we need to run the plant at higher LSF to achieve the higher values of halite for the better reactivity of the clinker. We can see here again that for the process preferred parameters, what we wish that the process conditions should be excellent, heating rate should be rapid, size of the halite should be in the range of 15 to 25 microns, and the maximum temperature can be attained as high as possible as per the requirement of the process, and the cooling should be at rapid speed. So we can see it here that the kiln torque, burning zone temperature, kiln inlet oxygen, CO levels, cooler undergrade pressure, and filling degree and hood drafts kept very consistent throughout our all the exercise. Now come to the this correlation part. We have used the Python Colab software, which is available on the internet, and we did the correlation with respect to everything which we can do. So when we see that these correlations with respect to chemistry, it helps us to understand that the certain parameters which are still which are there in the books are established parameters. So this is again supporting those parameters. Like since we have taken the bi-hourly data with the process and quality, the halite and vilite shows a strong negative correlation. Similarly, aluminate shows moderate positive correlation with MgO and sodium. So these are the established facts. Again, when we see the correlation with respect to mineralogy of the clinker which we have produced, the change in the modular value of the kiln feed has direct impact on the mineralogy formed during clinkerization. Increase in the alumina modulus has positive correlation with the aluminate formation with the 0.71 values. Again, the similar observation was observed with respect to silica modulus. That is strong correlation, negative correlation was observed with respect to silica modulus in the liquid formation. And again, with the free lime also, it is a positive correlation with respect to LSF. Now, correlation with respect to residue and mineralogy, since we kept, we don't want to make it more complex, so we kept the residue part in our entire process almost consistent at level of 14% at 90 micron. So we do not have much variation, observed much of variation in this. Again, with the correlation with respect to process parameter, since we have kept the healthy kiln conditions altogether throughout our operations, so we do not have much of the correlations observed in this exercise. Again, correlation with respect to process and mineralogy, we observed that the correlation in process parameter versus mineralogy has not much of significance in our case when we have operated with the stable kiln operation and consistent fuel. Again, the process, when we see these parameters on the individual basis, we can observe this is established again that the preferred process conditions will be like that only, that we have the burning zone temperature with respect to free lime, we can have a negative correlation. Again, the NOx level will support the support to reduce the free lime content in the kiln. Now, finally, what we want to conclude here is that with the preferred quality moduli and all these parameters, if we make a small changes in silica modulus, alumina modulus with LSF, at lower LSF values, we can attain a higher value of halide up to 65% with the XRD rate-weighted method that we have tested through XRD rate-weighted method. This is the XRD values. Further, heat consumption can be reduced by at least 8 kilocalories. Again, since we want to have a better reactivity, we want to have a better shape of the halide mineralogy. So what we observed that since our mines is again dolomitic intrusions are there in the mines, so when we have increased the MgO content in our raw mix up to a level of 4.5% in the clinker, we observed that there is a transition from the M1 to M3 phase of the halide content, which again is a established thing and again shows that the formation of small crystals of M3 is possible if we have little bit on the higher side of the MgO content. Now, if we conclude, then we can say that the results and this study, we can say that at the lower level of LSF, at around 86 to 89, we can achieve a better halide, a highly reactive clinker. Again, the process parameter supports when we operate the kiln at lower LSF, not very low, but 86 to 89 in our case. So this will again, we can say that it is again a support to the net zero, our targets, that we can achieve a better clinker, high reactive clinker with a lower LSF. That was the finding, and I wish that on this aspect we should work, everyone should work, and we should get a better outcome out of this study. Thank you.
Thank you.
Thank you. Thank you, Mr. Jayaprakash and Suresh, for the excellent presentation. Of course, this is the need of the hour to reduce the CO2 emission reduction. That will help a lot. Now, I invite the paper on the instrument role of energy audit for accelerating the plant energy efficiency, a case study.
Respected Chairman, sir, Co-Chairman, sir, NCB representative, and all the delegates. I, Ankur Mittal from NCCBM, going to present a case study over instrumental role of energy audit in accelerating plant energy efficiency. Before coming to the case study, I would like to start with a broader picture, that is world energy outlook and for Indian context. India is the 4th largest energy consumer in the world behind China, US, and European Union. We are consuming around 4% of energy globally, and our pace for per year energy consumption is accelerating by 10%. And India is on the way from becoming a developing country to developed country. We have high energy demand. And in the COP26, our Honorable Prime Minister, he has also stated that by year 2030, the power generated by the renewable energy sources should be 50% of total energy demand. We are highly dependent over the import of coal as well as oil. And at presently, 40% of our primary energy is being earned by the import. So right now, we have very low per capita energy consumption, that is 861 kilowatt hour. And the total generation capacity of India is 450 gigawatt. And out of that, only 170 gigawatt is being catered by renewable energy sources. Now, coming from Indian context to Indian cement industry, we are the pioneer in terms of energy efficiency. But there is a large variation of thermal energy uses and electrical energy uses within the plants. We have the plants that are consuming 76 kilowatt hour per ton of cement, and we also have the plant that is only consuming 56 kilowatt hour per ton of cement. Similarly, in terms of thermal energy, the average thermal energy consumption is around 740 kilocalorie per kg clinker, but there are plants that are using that in the range of 670 to 675 kilocalorie per kg clinker. So there is a delta of around 65 kilocalorie per kg clinker and 20 kilowatt hour per ton of cement between the average performance and the best energy performance. The coal cost analysis of cement plant indicates that on average 45% of total cost, it is borne by energy sector. And recently, this percentage, it had gone higher by 60%. And thanks to the PET scheme of Bureau of Energy Efficiency, that has created a very competitive environment in the cement plants. Around 90% of cement plants are covered in the PET scheme. That consumes 90% of energy consumption by total cement industry. With a very brief profile of NCCM, that how we are contributing towards energy efficiency, meeting target of energy efficiency and energy conservation in the cement plants. We have a white canvas having colors of compressor audit, waste heat recovery audit, energy audits, walkthrough assessments, etc. Besides of these sponsored projects, we are also working on some R&D projects, that is the use of gasification, where we are exploring the conversion of RDF into gas. We are also working over solar thermal energy usage in the cement plants, because till now we have seen that solar PV technology, it has been explored so much, but there are very less applications towards solar thermal energy uses. So we are also working on that, and we have shaken hands with BEE and NICE for the same purposes. Now, coming to the case study that I am going to present here is for the plants that is having a kiln of around 3,250 TPD with a total cement capacity of 1.4 million tons per annum. For grinding purposes, plant has single mills, for one for raw mill, one for coal mill and cement mill. And to cater the power requirement, plant has captive power plant capacity of 12.5 megawatt. The plant is well covered under PET scheme, and the target for the plant was given to save around 4,300 MTOE in the PET cycle of 3 years. So in our study, we explored over some ideas, and with a mutual discussion with the plants, we concluded that 14 projects were identified having a capacity to save 1.41 crores per annum. And in terms of MTOE, the target was around 4,390 MTOE, but and with these measures, the plant could able to save 2,900 MTOE. Even for this calculation, we have taken the least energy saving scenario, but still in that scenario, the plant was able to achieve most percentage of the given target. Now, out of this 14 ideas, I like to highlight only a few of the one. The one was to provide intermediate bin in the raw mill reject circuit. At the time of visit, what we observed that all the rejects were handled by continuous driven belt. So some of the times the material quantity was lessened, and in that case, power specific energy consumption was on the higher side. So what we recommended to install an intermediate bin, so that once level has been achieved for the reject material, it can be handled accordingly. The second measure was to remove the venturi that was provided in the tertiary duct. The plant had installed it for flow measurement purposes, but actually it was contributing towards pressure drop across the venturi. So we recommended to remove that venturi across the TAD And with that, there was a potential of saving of 65 kilowatt. We also recommended plant to split their kiln feed into two cyclones. It means if all the feed was introduced to the top cyclone, so we recommended that why not to divert some percentage, say 30% of the feed to the second cyclone. It would provide an opportunity for a larger size of explored area with higher heat transfer, that is co-current heat transfer, that will able to save 2 kilocalorie per kg clinker. The another measure that we recommended to plant to install AFR dryer for reduction of AFR moisture from 35% to 20%. Here, what we recommended to install AFR dryer with a heat source of coal. But I would like to highlight that nowadays we are working for modification of stellar dryer type instrument. We all are aware that in stellar dryer, it's a horizontal belt type dryer arrangement with a heat from a heat source of coal, biomass, natural gas. But in Indian plants, we have space constant. So what we are trying to use the cooler hot gases and to convert the horizontal arrangement of this stellar dryer to vertical type of arrangement. And with the help of BEE, we are going to start a demonstration project in one of the plant in Rajasthan. So I would like to end my presentation with a quote that is, a true conservationist is a man who knows that the world is not given by his fathers, but borrowed from his children. Thank you so much for your kind attention.
Thank you so much, Mr. Angul Metal, for the great presentation on the energy conservation. Now I invite the paper on increasing in cement mill 2 productivity with the use of online particle size analyzer.
Good morning to all. Myself, Pankaj Tiwari, I am representing JK Lakshmi Cement Sirohi unit. I am going to represent to increase in cement mill 2 productivity with the use of online particle size analyzer. As we are the part of JK organization, our journey of Sirohi unit has started in 1982 with established capacity of 0.5 million ton per annum capacity. Now the second unit was commissioned in 1995 with an installed capacity of 0.9 million ton per annum, and unit third was commissioned in 1996 with a capacity of 0.9 million ton per annum. At present, our cement production capacity is 4.785 million ton per annum. We have 3 kilns. Kiln 1 was established in 1982 with an installed capacity of 1500 ton TPD, and present capacity is 4750 ton per day. Kiln 2 was established in 1995 and installed capacity is 2500 TPD, and at present we are operating at 5125 ton per day. And similarly, in the case of Kiln 3, we are operating at 5125. Overall, the present capacity is 15,000 per ton. Now the influence of particle size on cement quality. The first of all, cement strength within 3 days. In order to meet the requirement of cement strength within 3 days, particle with a size of 1 to 3 micron should be as few as possible, less than 10%. At far as concern of 20 days strength, the strength of cement within 20 days mainly depend on the particle size within 3 to 32 micron, which only contribute the strength of 28 days. And it should be near about 70%. Now, there are 2 methods for saving for particle size analyzer. One is traditional method, which is known as sieve analysis. Sieve analysis, also known as gradation test, is a simple technique and possibly the most common method for ascertain the particle size. Intel allowing particle to pass through the stack of sieve with known opening size and second for 10 minutes as recommended by balls in 92 using a mechanical test sieve shaker. The main limitation of mechanical sieving is the range of particle size that can be analyzed often 45 micron to 125 millimeter, which makes it ineffective for material of very fine grain such as cement and other cementitious metal. In case of JKLC, we are using different type of fly ash from different sources. We are having 26 sources we are using. And the standard deviation of residue of all the supplier between is 17, and a standard deviation of surface is 118. That is very difficult to. Now, background behind online particle size analysis. Measuring particle size is the key parameter of quality control process and help in ensuring a high performance product in terms of overall cement and strength. In the traditional process, cement fineness was measured using the Blaine number or sieve number. The challenges of the technique is that it is a slow manual procedure and there are chances of error because of manual sampling. Not only does online PSD ensure a high quality product is produced all the time, but it also results in energy saving, cost saving, and can increase throughput. Online particle size analyzer in cement grinding section to dwindle the large power consumption demand of finish. Now, I am going to talk about online particle size distribution analyzer. It is based on laser diffraction technique. Laser diffraction technique particle size analyzer relies on the fact that the particle passing through the laser beam will scatter light at an angle that is directly related to their size. As the particle size decreases, the observed scattering angle increases. A scattering intensity is also dependent on particle size. Large particles scatter light at narrow angle with high intensity, whereas small particles scatter at wider angle, but with low intensity. Basically, the laser diffraction system consists of three parts: a laser, a source of coherent, intense light of fixed wavelength, a series of detectors to measure the light pattern produced over a wide range of angle, and a sample of presentation system to ensure that material under test passes through the laser beam as a homogeneous stream of particles in a reproducible. Now, the benefits of online particle size distribution laser. It gives optimization of process control through prompt monitoring of grinding fineness of raw meal and cement, faster availability of result for quality and process control, assurance of consequently high product quality, reduction of energy consumption by avoiding overgrinding, maximum utilization of raw material, decrease of output expression material during type of changes, user-dependent, fast and reliable measuring results. This is the trial data during the online particle size analyzer. We have collected the sample from 7 September 2020 to 8 October. And there is an average. Under 3 micron, it is 8.88. 3 to 30 micron, it is 45.98. Under 45 micron, 71.21. And the specific surface was 310.41. And residue was 18.27. And compressive strength in 28 days, it is 52.85. Now, this is a trial run conducted across the performance of online PSD on productivity as well quality of cement. We have compared the traditional method versus online PSD. 1 day strength, the standard deviation was 1.3 megapascal. But where in online PSD analyzer, the standard deviation is only 0.80 megapascal. In 20 days, strength in traditional method, the standard deviation was 1.59 megapascal in PPC grade, whereas in online PSD analyzer, we got the standard deviation of 0.32 megapascal. This is the residue of traditional method versus online PSD method. The standard deviation of before, it was 1177. After online PSD analyzer, it was only 5. The trial results compared with traditional method. In output was in 43 grade is 200 ton per hour, and after the installation of PSD analyzer, we got the result of 206. Means to say, we have increased our productivity by 6 ton per hour. 1 day strength is more or less same. 28 days strength is more or less same. And at the end of conclusion, our productivity has been improved by 6 tons per hour. Our specific power consumption of cement grinding section has been reduced by 0.956 unit per ton of cement. And we have reduced our carbon footprint by 1225 metric ton per annum. And the cost of installation is only 46 lakhs, and the payback is simply 6.7 months. Thank you.
Thank you so much, Mr. Pankaj Tiwari, for your clear database presentation on the online particle size analyzer usage. I think that ends our all the presentations. Now we can have the question and answer session.
My question is for first presenter, innovative approach to increase CBRM. My name is Mohammed Fazil from Ultratech Cement. Sir, you have increased your productivity by some internal changes in mill. So it's also impact fan RPM and PSD?
You can give the mic to him, please.
Yeah, the fan power which I have told, no, it has reduced by 148 kilowatt. It is because of the reduction of fan percentage. Initially we were able to operate at 98 to 100%. Now it has been reduced to 83% only.
Okay, productivity increase and RPM decrease.
Yes, yes.
Any change in PSD?
PSD?
I mean final material?
No. It is maintained as constant. 3,600 centimeters square per gram.
So you achieve double benefit.
Yes.
Okay,
thank you.
Anyone else? Yeah, I think.
Yeah, hi everyone. I am Kani Singh from JK Lakshmi Cement. I have a question to Mr. Ankur Mittal. In the case study, he was saying that what they did, they just diverted the feed in 2 cyclones. 30% of the total feed was diverted to cyclone 2, right? So in that case, the temperature of the top cyclone would have increased. So how that overall heat consumption got reduced in your case study?
Okay. Actually, that measure was suggested based on the heat transfer from gases to material. But as per the design constant, all of the heat was not being transferred to the material. So overall temperature of the gas was on higher side. But when we diverted the feed from in 2 cyclones, say only 20-30% to lower one cyclone, and all the major feed to the upper cyclone. So in that case, the heat transfer from gas to material, it was observed that it was on better side. So in the totality, there was saving of 2 kilocalorie per kg clinker. That was our observation. Thank you.
That was, I had also one observation on that. What is his name? Okay, that was good. Okay, the heat got transferred to the material, so that was reducing the heat consumption. But in our presentation, the exit temperature is also getting increased. That was mentioned. In fact, it has to come down because if the transfer is getting better to the material, the exit loss will come down, the temperature also will come down. Yeah, that maybe you can correct it. Yeah, thank you.
Yeah, Mr. Ankur, a small information, it is not a question. Do you have any data or NCB has any data? Means Indian cement industry is having different sources of power, captive power, grid power and all this. Do you have any ratio of overall industry power consumption, means electrical energy power consumption, grid versus captive and versus WHRS and all this?
Actually, right now I have the data available for Indian perspective, not for the sector wise. So in India, the total generation capacity is around 470 gigawatt, and out of that, 170 gigawatt is being catered by renewable energy sources.
Okay.
And for India, actually, for captive power plant, I can say some data about waste heat recovery, not for the captive power plant. So 900 megawatt capacity, it has been actualized by the waste heat recovery system.
WHRS as on date on generation is I think 600, 650 something like that. Maybe under installation, including that, maybe 900 plus. But my just query was, do you have details of captive power generation and all this? Then the ratio of all these three, if we can have, including solar power as a renewable power.
No, so no, I don't have the data
Okay.
right now.
I'll talk to you personally for that. Thank you.
Good. I think if there are no other questions, we can conclude the question answer session. I hope we already achieved the productivity enhancement, whatever the topics is, no? Because we already almost saved 10 minutes. So that shows our session was so powerful, and we already achieved the productivity enhancement in saving time also, right? So now I request our co-chairman to give his remarks. Yeah.
Okay. Good afternoon. Good afternoon. Chairman, Mr. Suresh, and all audience. In this session, total 7 papers were presented. This paper covers productivity enhancement with modernization, new technology adoption, process digitalization, and lab research. I have heard the first time name Python. Some Python I have to ask to from Jayaprakash. What is this? Lab research work. All cement industry need to work on adopt it, moving towards net zero carbon emission. Thank you.
Thank you. Thank you so much. No, for me it was really a very interesting session because we had all varieties of paper, right? Initially we started with innovative approach to reduce to increase the production by almost like from 370 to like 410, 40 tons per hour. It's not so easy. And the reduction of power consumption also. And then we had the Industrial 4.0 where we could see the latest usage of technology, including the mobile app and how to get the data synchronized and the mobile data bank system. All these things we had the very good intervention. Then we had the full detailed analysis of kiln, where what are the basic checks and if we miss it, what are the implications, and also the bell mouth, what is the importance and how to avoid it. And of course, then we had the paper from NCBM on the correlation of chemistry and process parameters. This is very, very important because now with the nowadays, as you know, the very big issue for all the cement industries is the natural resources. So if we are able to get a better clinker with the lesser LSF, of course, it is going to reduce the consumption of limestone, which is the very scarce resource. But only one input, instead of only seeing the clinker LSF, we also need to monitor the ROM, because I saw the alumina model somewhere like 1.5. So even though the clinker LSF is less, if you start adding more fire clay or something like that, the clinker LSF will be less, but the ROM will be higher. I request the presenter to have a monitoring on the ROM LSF also, which is very critical. Very good paper and good correlation, and all the parameters, including the strength, all parameters were improved with the lesser LSF. Then we had a paper on the energy audit, various initiatives. So that probably it will be very useful for the entire audience. They can directly implement it. And finally, we had on the cement mill productivity increase through online particle size analyzer. Okay, that was also, now earlier, as he rightly said, the old methodology of using the sieve analysis. Now, whatever the 3 to 30 micron through with the conventional sieve analysis, you will not be able to do it on a regular basis. So this OPSD is really helping us. So by and large, all were very good papers and very good variety of papers we had. And I thank the thank each and every one of the presenters for a nice presentation. Thank you. Thanks a lot.
Thank you, sir. Now we would request Shri Suresh to kindly present memento to our respected chairman and co-chairman as a token of respect. We extend our sincere thanks to Shri K. Vinayagamurthi and Shri Dinesh Kumar, Shri Suresh for their esteemed presence. So that concludes our technical session 10th A.